We're going to take a look now at hypothesis testing for means. And so now the variable in consideration or the population parameter will be a quantitative variable. And so we've already looked at proportions, hypothesis test for proportions. And so you'll see again, we have to now consider again the T versus Z inference procedures. And so in this section, we'll be doing a one sample t-test for the mean. And notice again the notation we use when we're looking at a hypothesis test for proportion. It's a p-hat, that's our sample data. X bar, the sample data for a mean. Right? And so we have the distinction of when we use a z, right? The data does not depend upon the standard deviation of the population. When the standard deviation of the population is considered, right? The population is almost always not known, so we use a t. The 5 steps we're familiar with, they're the same steps we follow for hypothesis testing for a procedure. And so again, we're looking at the idea of claims and hypotheses and how we test these claims. And so we're always thinking about what is our claim or what are we comparing our sample to, right? We collect the sample data and we use sample data as evidence, and think about what are we using it as evidence of what, right? And so we'll continue to look at that question as we have this first examples of writing hypotheses for means. This is the known alternative for these situations here. And so we collect this data. Let's say you do some sample data. Here you can see it. And we're testing the claim that the mean number of years of service at retirement is 25 years. Is this data, right? Here's the question, right? Evidence of what? Is this data evidence to reject the null hypothesis? Do we have enough evidence to do so, right? And that's what we'll do in a hypothesis test. But first we want to write the known alternative. In this case, it is 25 years or it's not equal to 25 years, right? And don't forget the units here. And I don't have units here, but there should be some units when you think about 25 what? 25 years. And in this case, is there evidence that the true mean runtime for all participants is below 30 minutes, right? And so we have the null and the alternative, right? And is this sample data enough to reject the null hypothesis? So that's your step 1. Or step 2 is naming the test. In this case, again, we're going to be running a one sample t-test. Step 3, the requirements. Right, we've seen this before, independent, random, large enough. You should be familiar with that since we've had to deal with that in confidence intervals, right? And we had to check, right, if we meet the requirements to run a confidence interval, and they are linked confidence intervals and hypothesis tests. Step 4 is to calculate a test statistic. This equation is different. It's different because in the proportions we use z, but you'll see the same format, right? It's like a z-score, but it's the t distribution. Since we're using the sample standard deviation instead of the population. Right, it's important to acknowledge there, right? Right there, since we're using S instead of sigma. You calculate the test statistic, and then we use the t calculator here. If it's a t, normal calculator for z, to check to see, right, what's the probability of observing that test statistic, right? Probably obtaining a result, or more extreme, right, given in the null hypothesis, right? Given if the null hypothesis is true, the p-value is a probability value. Okay, it's similar to the last one. And then we go ahead and find the probability, right, given that situation here. And so it's either going to be less than or equal to, or greater than or equal to, or if it's a two-sided test, when we have the not equals to, then you calculate one of them and then multiply by 2. But we'll talk more about that when we actually do one here. Go here, the tips for StatCrunch and for Artistat. And we'll stop right there.